This video is about derivative of absolute value function and the mean value theorem. Derivative of an absolute value function. If u equals to f of x, then d over dx of absolute value of u of x is equal to u prime times u over absolute value of u. So here is an example. Find the derivative of g of x equals to absolute value of 5x minus 3. So let's start with g of x equal to absolute value of 5x minus 3. Let u equals to 5x minus 3. Let's find u prime, which is equal to 5 times the derivative of x, which is 1, minus the derivative of 3 is 0. Simplify, it gives you 5. So u prime equals to 5. Now g prime of this given function is equal to u prime times u over absolute value of u, and that came from this formula. Now we just substitute u equals to 5x minus 3, and the u prime we just found equals to 5. So this becomes u prime changes to 5, u becomes 5x minus 3, and absolute value of u also changes 5x minus 3. Now we can multiply 5 with 5x minus 3. So 5 times 5x is 25x, minus 5 times 3 is 15. So the g prime x of this function is equal to 25x minus 15 over absolute value of 5x minus 3. The mean value theorem. If f of x is number 1 continuous on a closed interval ab, number 2 f of x is differentiable on an open interval ab, then there is at least one value c at which f prime c equals to f of b minus f of a over b minus a. Physical interpretation of the mean value theorem. Let s of t is the position function defined over an interval t1, t2. Then the mean value theorem says that the average velocity over a closed interval time t1, t2 is equal to the instantaneous velocity v at some instant t in the open interval t1 and t2. Mathematically, we can say s of t1 minus s of t2 over t minus t2 is equal to the instantaneous velocity v of t, where t1 is less than t and t is less than t sub 2. Geometric interpretation of mean value theorem. The slope of secant line through the points a, f of a, b, f of b is equal to the slope of tangent line at c in the interval a, b. That is. Example 1. Explain why the mean value theorem does not apply to the function f on the interval 0 to 6. And here f of x is equal to absolute value of x minus 4. So answer this question first. Number 1, continuity check. F of x equals to absolute value of x minus 4 is defined on every value on 0 to 6 as shown in the graph. And so f of x is continuous on closed interval. So first condition is satisfied. Number 2, differentiability check. So f of x is absolute value of x minus 4. So we differentiate with respect to x. And since this is an absolute value function, the first derivative of this is formula is u prime times u over absolute value of u, where u is x minus 4 and u prime is the derivative of this. The derivative of x is 1 and 4 is 0, so u prime is 1. So we substitute these values in this formula. So u prime is 1 and u is x minus 4, and here you can also put ux minus 4. So we have x minus 4 or x minus 4 absolute value. Now you can notice the f prime x is not defined at x equal to 4 because f prime 4 is 4 minus 4 over absolute value 4 minus 4 is 0 over 0. That is, f of x is non-differentiable at x equals 4. And 4 is between 0 and 6. Therefore, f of x is not differentiable on open interval 0 to 6. So we can conclude the mean value theorem does not apply because f of x is not differentiable on open interval 0 to 6. Example 2. Verifying the mean value theorem. Determine whether the mean value theorem can be applied to f on AB. If theorem is applicable, find all values of C in the open interval AB such that the f prime C equals to f of B minus f of A over B minus C. So here f of x is equal to 10 minus 16 over x and the closed interval is 2, 8. If the mean value theorem cannot be applied, explain why not. So let's start with f of x equals 10 minus 16 over x. Interval is 2 to 8. Number 1, continuity check. 16 over x is undefined for x equals 0. So f of x equals 10 minus 16 over x is undefined at x equals 0. But 0 is not in interval 2 to 8. Therefore, f of x is defined and is continuous on the closed interval 2, 8. Number 2, differentiability check. So let's start with f of x equal to 10 minus 16 over x. Let's rewrite 10 is 10 and we can move to the x to the top and make it x equal to minus 1. So now we have a 10 minus 16 times x to the minus 1. Now we differentiate with respect to x. 10 is a constant, so the derivative of 10 is 0. 16 just multiply, just bring it down. So here we apply the power rule, and that's it, bring down the power negative 1 and write the base x and subtract 1 from the exponent. So we have a 0 minus 16 times negative 1 times x to the negative 1, negative 1. Now minus 1 becomes minus 2. So we have 16 times x to the negative 2. Now I can rewrite 16 over x to the 2. And which is undefined at x equals 0. But 0 is not in the open interval. And so f of x is differentiable on the open interval. Since f of x is continuous on the closed interval 2, 8 and differentiable on open interval 2, 8, mean value theorem is applicable. Since the mean value theorem is applicable, so now we can solve this equation. F prime C equals to f of B minus f of A over B minus A. Here A is 2, B is 8, and f of x is 10 minus 16 over x. So we can find f of 2 and f of 8. So f of 2 is 10 minus 16 over 2, which is 10 minus 8, which is 2. And f of 8 is 10 minus 16 over 8, which is 10 minus 2, which is 8. Let's substitute f prime C equal to 16 over x squared. F of B equals to f of 8 equals to 8. F of A equals to f of 2 is equal to 2. In the formula, f prime C equals to f of B minus f of A over B minus A. So f prime C is 16 over x squared. F of B is equal to 8 and f of A is equal to 2. B is equal to 8 and A is equal to 2. Now we simplify. 8 minus 2 is 6 and 8 minus 2 is 6. So 6 over 6 cancel out to 1. So we have 16 over x squared equals to 1. Now we solve for x. Okay, so we have 16 over x squared equals to 1. Since x squared is on the denominator, we multiply each side by x squared. So we have x squared times 16 over x squared equals to 1 times x squared. Simplify, we multiply both sides by x squared. So x squared cancels with x squared. So we have 16 and 1 times x squared is x squared. Now we rewrite this equation, x squared equals to 16. Now we take the square root. Now this will be x equal to plus minus square root of 16, or x equal to plus minus 4. So now we have two values, x equal to negative 4 and x equal to positive 4. To decide which one of minus 4 and 4 is C value, we check which one is in the interval 2, 8. So you see minus 4 is not in the interval, so minus 4 is not a C value. But 4 is in the interval 2, 8, so C is equal to 4. Example 3. Determine whether the mean value theorem can be applied to f on the interval AB. If the theorem is applicable, find the value of C in the open interval AB such that f prime C is equal to f of B minus f of A over B minus A. And f of x is square root of 2 minus x, interval is minus 7, 2. And if the mean value theorem cannot be applied, explain why not. Number 1, continuity check. F of x equal to square root of 2 minus x. Interval is negative 7 to 2. Or x is between negative 7 and 2 inclusive. Square root of 2 minus x is defined for x less than equal to, because that's the domain of the square root function. And minus 7 to 2 is just a part of this domain. So if f of x is defined on x less than equal to 2, it's also defined on the given interval negative 7 and 2. So therefore, f of x is defined and is continuous on the given closed interval negative 7 to 2. Number 2, differentiability check. So let's start with f of x equals square root of 2 minus x. Now we rewrite, so 2 minus x to the power 1 half. Now we differentiate with respect to x using chain rule. So f of x becomes f prime x, and bring down the power down 1 minus 2, and 2 minus x to the power 1 half minus 1, and multiply with d over dx of 2 minus x. So this is equal to 1 half 2 minus x, 1 half minus 1 is negative 1 half, and the derivative of 2 is 0, and the derivative of x is 1, so it becomes negative 1. So now we simplify, so it will be 1 half times negative 1 is negative 1 half, and since a negative power we can bring it down and make it 2 minus x to the power 1 half. So we found the first derivative is equal to negative 1 over 2 times the square root of 2 minus x. Now what is the domain of this one? The domain of f prime x is 2 minus x bigger than 0. Or solve for x, give the x less than 2. So the domain is minus infinity to 2. Because at 2 the whole thing is undefined. And minus 7, 2 is a part of this domain. So if first derivative is defined on minus infinity to 2, then it's also defined on negative 7 and 2. That is, the f of x is differentiable on this open interval negative 7, 2. Now since f of x is continuous on closed interval negative 7 to 2 and differentiable on open interval negative 7, 2, mean value theorem is applicable. Now since the mean value theorem is applicable, we should solve this equation f prime c equal f of b minus f of a over b minus a. Now a is minus 7 and b is 2, and this came from the closed interval negative 7 to 2 that was given to us. Now we start with f of x equal to square root of 2 minus x and find f of negative 7. So f of negative 7 will be square root of 2 minus, replace x by negative 7. So this becomes 2 plus 7, so you have a square root of 2 plus 7, which is square root of 9, which is 3. Now we find square f of 2. So f of 2 would be 2 minus, change x to 2, have a square root of 2 minus 2, which is equal to square root of 0, which is what? 0. Now f prime c, we already calculated that as 1 over, a negative 1 over 2 times square root of 2 minus x. So we now substitute f prime x 1 over, negative 1 over 2 times square root of 2 minus x, and f of b, which is f of 2, which is 0, and f of a, which is f of negative 7, and that is 3 in this equation. So this equation becomes negative 1 over 2 times square root of 2 minus x equal to f of b is 3, f of a is 0, b is 3, and minus a is negative 7. So this becomes 3, and this becomes 2 plus 7, 9, which becomes 1/3. So now we solve the equation negative 1 over 2 times square root of 2 minus x equal to 1 over 3. So it looks like we can find the cross products. We can multiply 1 times 2 times square root of 2 minus x, and the right side multiply 1 times 3. So, and keep the negative sign on the left side, and simplifies. 1 times 3 is 3, so you have a negative 2 square root of 2 minus x. We are solving with x, and x is under the radical sign, so we square both sides. So we have a square of negative 2 times square root of 2 minus x equal to square of 3. So when you square this one, minus 2 becomes 4, and the square of square root of 2 minus x becomes 2 minus x, and square root of 3 becomes 9. Now we distribute 4, so 4 times 2 is 8, and minus 4 times x equals to 9. Now we move the 8 to the right, and you're left with negative 4x equal to 9 minus 8, which is 1. Now we divide both sides by negative 4, so we have negative 4x over negative 4 equal to 1 over negative 4. This cancel out, gives the x equal to negative 1, 4. And negative 1, 4 is in the interval minus 7, 2. So therefore c is equal to negative 1 over 4. Example 4. The height of an object at t seconds after it is dropped from a height of 300 meters is s of t equals to negative 4.9 t squared plus 300. Question A. Find the average velocity of the object during the first 3 seconds. So first 3 seconds mean the interval is 0 to 3. And we find s of 0 and an s of 3. So s of 0 is equal to negative 4.9, and when the t is put 0, it becomes 0 squared plus 300. Now this becomes 0. So the answer is s of 0 equals to 300 meters. So let's find s of 3. So we substitute 3 back in this equation, and we have a negative 4.9 times 3 squared plus 300. So if you simplify using calculators, we should get 255.9 meters. Now the average velocity is s of 3 minus f of 0, 3 minus 0. So s of 3 is 55.9, and s of 0 is 300 over 3. So if you subtract, gives a negative 44.1 over 3, and if you divide, gives a negative 14.7 meters per second. So example 4, part B, is I use the mean value theorem to verify that at some point in time during the first 3 seconds of fall, instantaneous velocity equals the average velocity, and find the time. So in part A, we found the average velocity is negative 14.7 meters per second. Now find the instantaneous velocity. So let's start with s of t equals to negative 4.9 t squared plus 300. Now we differentiate with respect to time t. So s of t, the derivative of s of t becomes the velocity vt, which is s prime t. Now the derivative, negative 4.9 times the derivative of t squared is 2t, and plus the derivative of 300 is 0 because 300 is constant. So we simplify, so the velocity at time t is negative 9.8 t. So to find the time equals instantaneous velocity minus 9.8 t and the average velocity of negative 14.7 found in part A. So we have equation negative 9.8 t equals to negative 14.7. Now to solve this one, we divide both sides by negative 9.8. So we have a t equals to negative 14.7 divided by negative 9.8. So negative divided by negative becomes positive, and when you divide, it gives you 1.5 seconds. So the answer is 1.5 seconds.